In this video, we discuss how we can use standard reduction potentials that are given for half reactions for all elements, how we can use this information to determine in a galvanic cell with two half reactions given, which one will be oxidized and which one will be reduced. So a common type of information that would be given is this table, again, Appendix L in the textbook. This is a subset of that. So we first show half reactions, and again, recognize that in these half reactions, these are all reduction half reactions. So we are provided with their standard reduction potentials measured in volts. Again, that subscript red stands for reduction. We are always provided this information as reduction half reactions. To determine what will be oxidized and what will be reduced, we can actually think of this in terms of oxidizing and reducing agents. So notice in here, I have added information about the increasing strength as oxidizing agents. Remember that an oxidizing agent is a substance that gets reduced. Notice that since these are written as reduction half reactions, these reactants, these specific substances are the ones being reduced. So this is describing the oxidizing agents. On the right side, notice we have an arrow going down that is describing the increasing strength of reducing agents. Again, remember that reducing agents are substances that get oxidized. And so that is describing that the products of these reactions are actually the reducing agents. Now, how we know the relative strength of these is based on reduction potentials. The more positive a reduction potential, the easier that substance is to reduce. So looking at this list, notice that fluorine at the very top means that fluorine gas out of all of the substances in the periodic table is the easiest element to reduce. Notice at the bottom of this list, we have the lithium ion. And lithium as a metal, we know would rather be oxidized than reduced. And so lithium ion is the hardest substance to reduce out of all of the elements in our periodic table. Something else I want to draw your attention to is here we have a subset of standard reduction potentials, and focus more on the list of substances shown here. So again, these are reduction potentials. They're gaining electrons. Don't focus on these reduction potential values here. What I want you to compare this to is the activity series that you used in Chem 151 to determine if a single replacement reaction would happen. So again, let's go back and forth. Here is our list of standard reduction potentials. And again, focus on the order of elements given in the half reactions. Now compare that to the order of elements in the activity series list. What do you notice about the order of these two? Hopefully you identified that they are exact opposite series. So recognize in the activity series, we are showing oxidation half reactions versus in our reduction potentials, where we're showing literally reduction half reactions. So hopefully it makes sense to you that these two lists should be in exactly opposite orders. So in other words, in 151, when you were using the activity series, that series was actually developed by using reduction potentials for half reactions of each substance. So as a quick summary of the list that I gave you, fluorine is the best oxidizing agent. because of that list, it was the easiest one to reduce, the easiest substance to reduce. And hopefully the fact that it has the most positive reduction potential value makes sense. Remember that fluorine is the most electronegative element, and so it easily gains electrons. Adding to that, we saw that the lithium ion had the most negative reduction potential, meaning that lithium ion of the list I gave you is the hardest one to reduce. However, what that also tells us is because it's the hardest one to reduce, if I reverse this equation and write it as oxidation, and then write my oxidation potential of a positive value, now it turns out that lithium solid of that series is the easiest one to oxidize. Since it's the easiest one to oxidize in that list I gave you, that makes it the best reducing agent. So one more activity to make sure the idea of oxidizing and reducing agents makes sense. If I give you this list of 4 half reactions, reduction half reactions, and their reduction potentials, I want you to determine which specific substance, including physical states, is the best oxidizing agent, and which specific substance in these equations, including a physical state, is the best reducing agent. I want you to pause the video. When you have your answers to these, start again, and then I will show the answers for them or work through the answer. All right, so for our scenario with these 4 half reactions, I'm actually going to go back to this screen. So realize if I'm looking for the best oxidizing and reducing agents, what I need to know are the most positive and most negative reduction potentials. So the first thing I'm going to do is cross out my 2 middle reactions, because I want to look at my most positive and my most negative reduction potentials. The other thing I want to do is remind myself, if I'm looking for the best oxidizing agent, remember that that's the substance that gets reduced. If I'm looking for the one that's the easiest to reduce to determine the best oxidizing agent, I want the most positive reduction potential. If I want to identify the best reducing agent, I'm looking for the substance that will get oxidized. And I want to look for the one that's the easiest to oxidize. So essentially, I need to determine the most positive oxidation potential and what that reactant is. So again, going to our next slide, I'm going to write down that information. So we had gold ion reduced down to solid gold. And that one had a reduction potential of 1.498 volts. Since this reaction has the most positive reduction potential, it means that of that list, gold ion in the aqueous form is the easiest to reduce and therefore is the best oxidizing agent. At the bottom of my list, I had nickel 2+ being reduced down to nickel solid with a reduction potential of negative 0.257 volts. Now, since this has the most negative value of that list, I'm actually going to convert this into the oxidation half reaction. And I recommend writing this out. Trying to do it in your head and then paying attention to how you have your equation written is difficult to do, especially as we get into practice calculations coming up. So I strongly recommend, as you're identifying this, flip your equation and then determine your new cell potential or reaction potential. So now that nickel is oxidized, it has an oxidation potential of positive 0.257 volts. Since nickel solid is what's getting oxidized, and of that list, it is the easiest one to oxidize because it is the most positive oxidation potential, nickel solid then is my best reducing agent. And so again, we can use this information, the same way to interpret, to set up which equation will be oxidized and which will be reduced when we combine two half reactions in a galvanic cell. So just as a quick summary, here's the answer slide. Our best oxidizing agent is gold ion in the aqueous form. And then our best reducing agent, the one that's easiest to oxidize, is the nickel solid because we flipped that equation.